If I have everyone's attention, I want to introduce our speaker tonight. Our speaker is Larry McHenry. He's a Pittsburgh resident, and he's actually done a number of talks for us. He's done at least a couple of talks for us virtually over the years, through COVID years and other ways. But being from Pittsburgh, it's not that easy to get him here. See Larry at the Star parties down at Cherry Springs all the time. So I asked if he would come here in person, and he was glad to come and camp. And he's so far so good. We just got to cover up green light very much.
Yeah. The Death Star there earlier that we found last night, but other than that, sorry.
So he part of the Kiski astronomers in the ORAS, Oil Region Astronomical Society, and he loves talking about the historical forefathers in astronomy. So very specific guys in astronomy, and he has a passion for the objects that these guys are finding. So today, Larry's going to be talking to us about planetary nebulae. His title his talk is Planetary Nebulae from Messier to Abel. What are they? How to observe them? And they're colorful, ephemeral ghosts. And I'll let Larry talk about the rest of it. So
all right, awesome. Thank you, Mike, and also I'd like to thank Azra for inviting me here tonight to your facility at the Parish Center. And it's a beautiful observatory. You guys should be very proud of it. It's an amazing facility for someone who's never been here before. But again, thank you very much. There is a handout floating around here. Again, Planetary Nebula you might see tonight, depending on what the weather does for us. More importantly, though, it does have my website on this. There's some chart addendums. I'll tell you how to download in a little bit. And also my email address is on here. So that way, we'll take questions at the end of the presentation. But if you think it's something after the fact, you can email me and say, hey, I saw you at the Azra's Star Party, and here's what I like to know about Planetary Nebula. So there are a few copies left here. If anybody needs one, we can grab those later. So again, my name is Larry McHenry. I am an amateur astronomer from Western Pennsylvania, the Pittsburgh region. Belong to a couple clubs out there, the Kiski Astronomers, which at this point is kind of a virtual club, and then a bigger club called the Oil Region Astronomical Society, ORAS. We put on an annual event, Star Party, called Astroblast, and that's usually in the fall. It's coming up this October. All welcome to come down and check it out. But tonight we are going to talk about planetary nebula. What are they? And some tips on how to go about observing them. We're going to look at some examples of planetary nebula. Hopefully, again, we get a chance with weather cooperates. We'll do a little bit up on the hill there tonight. So, planetary nebula. When I hear that phrase, I think of a specific type of deep sky object, a type of object that's interesting and fun to observe or image. They also bring to mind their descriptions: colorful ephemeral ghosts, luminescent wispy shells, little crystal ball gems up in the night sky, delighting us amateur astronomers using small or large telescopes or imaging kits. They run from easily located extended disks that show great detail to tiny, almost pinpoint, challenging to find. But all are interstellar graveyards, giving up the secrets of their stellar evolution while spreading their wealth of star-forged elements across space to be swept up by gravity to enrich the next cycle of star birth. So today I'm going to try to bring these ethereal objects down to Earth, so to speak, by discussing what they are, why we call them planetary nebula, some of the people, both historical and modern, behind planetary nebula catalogs, and of course how I go about observing them. Hopefully when we're done tonight, some of the mystery around these objects will have been lifted, and you'll find them as interesting to hunt and observe as I do. So high level, what we're going to talk about, what are planetary nebula, just sort of level set on what those objects are for those new to the hobby, how they got their name, how to go about observing them, some various tips and techniques. Then we're going to talk about the historical modern astronomers, some of their catalogs, examples from them, and then we'll wrap up this presentation and take questions. I figure we should be done by 11 p.m., no problem. Let's get started. Maybe we'll be done by 10:30 then. So what are planetary nebula? Planetary nebula are clouds of interstellar matter, thin shells of ionized gas and dust. They mark where a star is slowly dying. These nebula come in a wide variety of shapes and appearances. The central star that creates the planetary nebula is in an advanced state of stellar evolution at or just beyond its nuclear life cycle. When a star similar in size to our sun has used up all its nuclear fuel, it first expands into a red giant star. But eventually, the force of gravity causes that star to contract. And during that process of contraction, a significant portion of its mass is ejected into a gaseous shell, forming a planetary nebula. Eventually, the star collapses down to a white dwarf star, which, as we learned today during the one presentation by Craig, this is the fate of our sun in a few years. Don't lose sleep over it, though. Ultraviolet radiation, light from the dying star that then energizes the shell of expanding gas. Perfect. Causing it to appear as a brightly colored nebula. Now, planetaries are generally classified into three types: spherical, elliptical, and bipolar. Some of these shapes are due to our line of sight angle with the object, how it's projected in space, but also the shapes are formed or sculpted by magnetic fields, stellar winds, interactions with other nearby stars that can produce a wide variety of shells and disks that we can observe. Most planetary nebulae are just a few light years or less in diameter, and they generally last only a few tens of thousands of years. So in cosmic timescales, these nebula undergo rapid changes such that those that we observe today are all fairly young objects. Over a period of time, though, the central star cools down and gets into that white dwarf star, and then the nebula eventually will fade from view, disappears. It's still there, it's just not illuminated. Now, why do we call these things planetary nebula? Where did that come from? So, a lot of amateurs mistakenly credit Charles Messier for naming these types of deep sky objects, but that's not correct. Messier in 1764 did discover what would become the first planetary nebula, M27, which we observed last night. From what I understand, nicknamed after Mark. In the constellation of Vulpecula, and as he professed last night, it's listed as catalog of nebulous objects for comet hunters to avoid. Messier, with help from fellow French astronomer and comet hunter Pierre Macon, went on to add three more of these objects to his catalog: M57, M76, and M97. But he never described them as resembling planets. It wasn't until nearly 20 years later by another astronomer that these type of objects were begun to be described as planetary nebula. In 1782, William Herschel, the discoverer of the planet Uranus a year earlier, first used the term planet in his description of these objects. Quote, "These bodies appear to have a disk that is rather like a planet, that is to say, of equal brightness all over, round or somewhat oval, and about as well defined in outline as the disk of the planets." End quote. Now, while it's possible that Herschel had read a previous description of M57 in this obscure Italian scientific paper, where the author described planetary nebula as looking like planets, it could very well be that Herschel had planets on his mind from his discovery of Uranus, as he was always keeping his eye out for finding additional solar system members. After all, he discovered one planet. Why not find a second or a third? Herschel went on to use the term planetary in his publications for these objects, whose characteristics, again, were a well-defined round or oval shape, equal brightness across the disk. So the credit of popularizing the term planetary nebula goes to Team Herschel. Now, how do we go about observing these planetary nebula up in the night sky? Well, planetary nebula can be found scattered throughout all four seasons of the night sky. There are currently over 3,000 planetary nebulae that's been identified. More are being constantly discovered. Most of these nebulae that we can visually observe, though, are located in the spiral arms of our home galaxy. And it can be found along the glowing band of light that we call the Milky Way. That's it's one of those TVs. Absorbs the red laser. But anyways, I don't need it. But the glowing band of blue light that we call the Milky Way, the spiral arms of our galaxy. That's where you're going to find the planetary nebula. Unlike the irregular glow of diffuse emission nebula, most planetary nebula do live up to their name in that they are generally circular shaped objects that somewhat resemble the shape of a planet. Some are evenly brighter illuminated across the disk. Others have a darker central region, giving them a ring shape. And some planetaries, the central star that's on its way to becoming a white dwarf that created the nebula, can still be seen. Some examples of planetary nebula that have bright, prominent central stars that are still easily visible: NGC 40 and Cephas, which will be up tonight. Let's see what else. NGC 6826 and Cygnus, Able 43 and Ophiuchus, M27 and Vulpecula. Again, depending on how big of a telescope you have. Visually, if the planetary nebula's surface brightness is high enough, you might be able to see color in your telescope. Now, most of the dimmer planetary nebula will just have a sort of a grayish color. The brighter planetaries will show some variation of green for the most part, maybe blue, maybe a little hint of red, depending again how big a scope you got. The easiest to see colors in are M27, the Dumbbell Nebula Vulpecula, M57, the Ring and Lyra, NGC 7662, the Blue Snowball and Andromeda, and NGC 6905, the Blue Flash and Delphinius. And those last two, their nicknames kind of give you a hint as to what color you're going to see out of those guys. Now, these colors are from double and triple ionized hydrogen, oxygen, caused by the intense UV radiation from that central star. When the atoms drop down to a less excited state, they emit either a greenish or reddish light, depending again on the wavelength. To see colors in planetary nebula, you want to look directly at them. You do not want to use your averted vision. Your eye's color receptor cones are located at the center of your eyes, not on your sides. And as I was telling a couple of the guys last night, I know some planetary nebula observers who will take a small white flashlight. They will flash their observing eye to activate those cones, and they'll quickly look in the eyepiece and see if they see color in that nebula. Of course, that screws up the rest of their night vision, but they don't care. They want to see color in planetary nebula. So you can do that if you want to do that.
You do it?
I've never done that. No. I observed. I'm an EAA observer, so I'm not really a visual person. So I've never tried that through a large telescope, but maybe tonight. So the majority of planetary nebula are stellar in appearance, especially the Minkowskis, or they're exceedingly faint, like the Abels, needing a specialized line filter such as an O3 filter, or maybe even a spectroscope to be able to identify them. Narrowband filters such as Lumicon's UHC, Orion's Ultrablock, Optilong's L-Enhance will help to visually see these planetary nebula. But if you don't have one of those narrowbands, if you just have a general broadband light pollution filter that you can get from, you used to be able to get from Orion, but from any dealer, they will help, though not as much as the narrowband. So basically, whatever you got, try it. Now, while planetaries can be classified into three generic types that I mentioned earlier: spherical, elliptical, bipolar, there's a more detailed classification system that was created by Boris Vorontsov-Belyaminov in 1934 that is still used today. You'll see it denoted in catalogs as VV. And here's the descriptions. They run class 1, stellar, star-like, hard to identify. 2, smooth disk. 3, irregular. 4, ring. And so on. Depending on the complexity of the shell structures, some planetaries have multiple combinations of these classifications. So, like for example, the Ring Nebula is classified as a type 2 and 4, disk and ring. These classes will give you a good idea of what to expect when viewing the nebula. So a good rule of thumb is that any planetary nebula that has a M number, Messier number, an NGC number are observable extended objects with disk or shell structures that you can observe. Most of the IC numbered planetary nebula, though, are generally tend to be stellar type objects. Some of them have small disks. But again, the smaller stellar ones are very hard to distinguish from field stars. Now, the largest planetary nebula that we can observe is NGC 7293, the Helix Nebula, in the fall constellation of Aquarius. Due to its large, dim, ring-shaped size, about half the apparent diameter of the full moon, the helix is generally best observed with a wide-field, medium-sized aperture telescope. The brightest planetary nebula that you can observe, NGC 7009, the Saturn Nebula, is also located in the constellation of Aquarius. So you kind of get a twofer if you stay up a little bit late night. You see both the biggest and the brightest. But due to its small size, the Saturn Nebula, you're going to need at least a somewhat large size telescope to see any detail within its structure, such as the ANSI that gives it the Saturn Nebula nickname. Now, some ingredients to successfully observe planetary nebula or to image them. In general, for visual observers, it's best to hunt planetary nebula starting off with a low power, wide field eyepiece to identify your target area. This is all common sense stuff, too, that we all probably admit this for any object. But once the planetary is centered, then you can switch to higher magnifications and filters, try to pull out details in the nebula shells along with the central star. Use as high a power magnification as you had. This is the time to pull out and dust off those 4mm Naglers that you've been hoarding and use them on planetary nebula, because planetary nebula will take the power. They'll take the magnification. Messier's 4 planetaries, with the exception of M97, are high surface brightness objects and are easily visible in most telescopes, even under suburban skies. The 20 planetary nebula from the Herschel catalog are also generally visible in medium-sized or larger telescopes, though some, again, will require the bigger scopes, 12, 15-inch or bigger, to see them, and of course, a dark country sky location. But the planetaries listed in the Abell catalog are generally very old, extended, and faint, and makes these objects very challenging to observe. The Minkowski planetary nebula are also difficult to observe, with many of them appearing star-like, embedded in crowded Milky Way fields, showing little to no disk nebulosity. Again, for both of these, you're probably going to need a 17-inch larger telescope, or again, some type of imaging kit. But regardless of how you observe planetary nebula, whether you're a visual observer or you're an imager or EAA, it's kind of hard to see here, but the thing that you want to have is an observing plan or a planetary nebula catalog or an observing guide. Be prepared. Be a Boy Scout when you go out there to observe. Don't wait till you're out there in the dark sky and think, oh, what planetary nebula can I see tonight? Prepare in advance a list of the objects you're going to observe. That's actually good advice for any kind of observing. So, speaking of observing guides, there's a number of good planetary-related observing guides available to us amateur astronomers. Here's a couple of my favorites. The Night Sky Observer's Guide, Volume 4, Glories of the Milky Way by George Keppel, who is a member of the Kiski Astronomers. This is the 4th handbook in his series of Night Sky Observer's Guide that him and Glenn Sander wrote together. Each chapter in the book covers a specific constellation, finder charts, sketches, images, visual descriptions of various deep sky objects. And again, Volume 4 focuses on constellations and their objects that lie along the path of our Milky Way. He doesn't talk about galaxies at all, hardly. But each constellation chapter in the book lists all the planetary nebula visible within the boundaries of that constellation in a very convenient list under each constellation chapter. Highly recommend that book if you can get it. Another good handbook to have, though somewhat dated, is the Webb Society's Deep Sky Observers Handbook series. Volume 2 of that handbook series, called Planetary and Gaseous Nebula, lists a number of bright planetary nebula visible with small to medium amateur telescopes. there are a total of 80 planetary nebula listed in the Webb Society Handbook with detailed descriptions and sketches of each one. Again, it is a little bit dated, but if you can find it, it's a good resource to have. Finally, we're on the internet, we can find anything. There's a number of good amateur astronomy related guides by amateur astronomer Alvin Huey at his website, faintfuzzies.com. And I don't know if anyone's ever been to his website or not, but I mean, this guy's done a great service to us amateur astronomers by putting together these PDF books of all kinds of deep sky objects, galaxies, clusters, planetary nebula. First one of his is called Planetary Nebula and Supernova Remnants. It lists over 300 planetaries with finder charts, DSS images. It's a mixture of easy to hard to find, so it's useful to both beginners and the more advanced or intermediate amateur. Alvin also has another handbook called the Abell Planetary Observer's Guide, and this handbook is definitely for the more advanced observer looking for a challenging visual or imaging project. Both handbooks contain finder charts, again, digital sky and DSS images, visual eyepiece and sketches made by the author using his 22 or 30-inch Dob telescope. Again, most of these are free. You go to his website, you can download them free. I think there's a handful that he still charges a little bit for, but you can download them, save them to your favorite electronic device, or you can, he's got these things laid out so you can take them to FedEx or Kinko's and print them out and have a manual in the field, which is what I've done with a lot of them. Also, another one that you can find on the internet is called the Brightest Planetary Nebula Observing Atlas by Massimo Jetchin. That was a handful. It's a downloadable PDF of the best 35 planetaries across the sky, many of which have a high surface brightness observable with small telescopes from a suburban location. Again, you can either download it in a black formatted PDF or a white formatted PDF, depending on how you want to view it on your screen. We'll get both of them if you want. They include finder charts, object info, and a sketch by the author. And there's a website. It's called pnebula.altavista.org. But just Google the Brightest Planetary Nebula. That's probably the best way to find this thing. So we've covered what are planetary nebula, how they got named as such, and general tips how to observe this type of deep sky object. But who are these people that I've mentioned along the way? Messier, Herschel, Abell, Minkowski. Let's spend a little bit of time digging a little bit deeper into the background of some of these historical and modern astronomers associated with these catalogs of planetary nebula. Starting with our favorite, Charles Messier. So, in July of 1764, while out comet hunting, Charles Messier ran across a bright nebula that would become the 27th object in his list to avoid while you're out comet hunting. Messier referred to M27 as, quote, a nebula without a star. It appears of oval shape. That's all he had to say about it. But this was to become the first planetary nebula ever discovered, though, again, it took 20 years later and another astronomer to realize that's what they were. But who was Charles Messier? Well, the 18th century French astronomer Charles Messier is best known to us by his catalog of nebula and star clusters, first published in 1771. This list of eventually 110 deep sky objects is known to today's astronomer as the Messier catalog. As an astronomer, Messier's primary job was to hunt for comets. During his comet searches, he kept running into these diffuse objects that would frustrate him. He would waste hours tracking them, sometimes almost the entire evening tracking them, to finally realize these things weren't moving. So Messier began to keep a list of these objects to help comet hunters avoid these false comets. Messier also worked as an astronomer for the French Navy. His observatory was located within the city of Paris at an old hotel that was originally a medieval townhouse built in the year 1334. The observatory was built on top of a tower, it was a wooden structure with large windows that could be opened in any direction. Inside was kept the portable observatory telescopes that could be positioned to point out whichever window the observer wanted to look at. There was no permanently mounted telescope. For the majority of his observing work, Messier used a small portable 4-inch refractor as his favorite telescope. And just an interesting note from another talk. So on these telescopes, back during that time period, interchangeable eyepieces really weren't a common thing at that time. So each telescope had a fixed eyepiece and a magnification. So you might start out with a low power telescope, you point it out the west window, you see something like, what is that? Well, no, this thing doesn't quite show it enough. I have to go get another telescope, bring it over, point it out the window, and reacquire the object. Can you imagine doing that? Crazy. So, but anyways, over the course of his lifetime, Charles Messier did discover 21 new comets, and he was involved with like close to 40 some re-observations of returning comets. So he's a very prolific comet hunter. But it's his list of diffuse objects to avoid while you're comet hunting, his catalog of nebula and star clusters that today's modern amateur astronomers seeks out as the bright showcase galaxies, nebula, and star clusters of the night sky. This is what Charles Messier, nicknamed by the King of France, the Ferret of Comets, is known for today in the 21st century, not his comet discoveries. So let's step through Messier's planetary nebula examples. There are only 4 of them, so we'll go through them here. First up, again, M27, known as the Dumbbell Nebula, also later called the Hourglass Nebula by John Herschel, is located in the summer constellation of Opecula the Fox. It was discovered in 1764. It was the first planetary nebula again ever observed. It's one of the brightest, most impressive, easily visible in binoculars. M27 is about 1,360 light years distant, estimated to be close to 14,600 years old, and it's about 3 light years in size. And again, it's located right here in Opecula, kind of in the middle there, but it's fairly easy to find. On summer evenings, it is well placed almost directly overhead, and it can be a naked eye object from a dark sky location. Due to its high surface brightness, M27 can even be observable through a small telescope or binoculars with a bright moon in the sky. Its central white dwarf star shines at magnitude 12.9 and is visible in the center of the dumbbell shape using medium to large size telescopes, also depending on the transparency. Distinct structural features can be observed within M27, including bright, sharply defined arcs coming off either end of the dumbbell shape, along with striations between the main arcs and center of the nebula. Again, UHC filters, oxygen 3 filters, any kind of narrowband filter will enhance the internal features of this planetary nebula. Next up, M57, located in the summer constellation of Lyra the Lyre. The Ring Nebula, as it was the second planetary nebula, discovered by Messier in 1779, almost 15 years after M27. It's easy to locate, can be observed with small telescopes, even in suburban skies. It's about 2,300 light years distant, about 6,000 years old, estimated to be diameter of about half a light year, and they've measured it. It's expanding at 12 miles per second. With its high surface brightness, the ring is one of the best celestial showpieces up in the summer sky. While the nebula itself is easy to observe, the central star shines at magnitude 15.4. It can be quite difficult to observe. You definitely will need a large telescope or an imaging kit. Interestingly, 3D modeling of the come in. Anyways.
Nothing urgent.
It's the neighboring fire department.
Okay. Yeah. All right. We'll continue on until we have to evacuate. So, but interestingly, 3D modeling of the structure of M57 shows that it's actually similar in shape to M27. The difference in shape is a matter of our viewing angle perspective. For the ring, we're kind of looking down one of the axis of its ends. For M27, we're kind of looking at it broadside, like a 90-degree difference basically in rotation. M76. And if you stay up late enough tonight, you can observe M76. Located in the fall constellation of Perseus, the hero, the Little Dumbbell Nebula, as its nickname, was discovered in 1780 by Messier's observing partner, Pierre Macon. It's about 2,500 light years distant, about 6,000 years old, and it's about 1.5 light years diameter. Before it was determined that M76 was a planetary nebula, which didn't happen until the year 1918. It was once considered to be two separate emission nebula and was given two separate NGC numbers, 650 and 651. Visually, though, it's not difficult to find, and it does resemble its larger namesake in medium-sized telescopes. It does look a little bit like a small version of the dumbbell. Finally, M97, located in the circumpolar constellation of Ursa Major, the Great Bear. It's also known as the Owl Nebula. The last planetary nebula on Messier's not a comet list was discovered in 1781, again by Pierre Macon. The owl got its name based on a sketch made in 1848 by the third Earl of Rosse using his 72-inch reflector. It's about, again, 2,000 light years distant, about 8,000 years old. M97 is located near the bright Dipper Bull star Merak Beta Ursa Majoris, which normally would make the planetary, you would think, kind of easy to find. But because it's fairly faint, it does require a medium-sized telescope, at least to see visually. The bigger scope you have, the better M97 will look for you, or, again, an imaging kit. William Herschel. In William Herschel's catalog, one of the major classification categories, Class 4, is called Planetary Nebula. There are a total of 77 objects listed in this catalog, this category. And we're not going to talk about this. But only 20 of these are true planetary nebula. Herschel was known for dropping objects that he wasn't quite sure on how to classify into this category. It was his catch-all junk drawer, so to speak. So, who was William Herschel? Well, after the Messier list, the Herschels are the next most observed deep sky objects. Most amateur astronomers know them by their NGC numbers, but they started out as a list created by British astronomer William Herschel and his sister Caroline Herschel. For his discovery of the planet Uranus, King George III of England in 1782 knighted William Herschel as the king's personal astronomer. This gave William an annual pension. This allowed William and his sister Carolyn to retire from their profession as music teachers and vocalists and devote themselves full-time to astronomy. Using his new wealth, Herschel's relocated to a small village in the countryside within a mile of Windsor Castle. They built a new permanently installed giant telescope called the 20-foot reflector, which actually had a mirror of 18.5 inches diameter made out of speculum metal that you had to polish. Glass mirrors were not in vogue at that time. They were a few years away yet, the silver glass mirrors. From 1782 to 1790, using the 20-foot reflector, the Herschels conducted systematic surveys of the night sky in search of deep sky objects, and they discovered close to 2,500 objects. In 1834, John Herschel, William's son by his wife Mary, he restored the 20-foot telescope. Then he took it to Cape Town, South Africa, where he added another 1,700 objects to the list. Eventually, all the Herschel objects, along with the discoveries of some other astronomers from that time period, were combined, published in the year 1888 as the New General Catalog, abbreviated NGC. And this is where the NGC comes from William Herschel's original list. William Herschel was one of the most notable observers in the history of astronomy, and he's often referred to as the father of observational astronomy, which would make his sister Carolyn the mother of observational astronomy. And as most stargazers do today, all of his observations, both of them, were made outside in the open, exposed to the elements, not from inside an observatory building. So let's just run through a couple of bright Herschel examples that we try for tonight. First up, NGC 40, located in the fall constellation of Cephas the King, nicknamed the Bowtie Nebula. It was discovered by Herschel in 1788. About 3,500 light years distant, about 1 light year in diameter. Visually, NGC 40 has a little bit of a greenish cast to it, a little blue-green oval. It has a 10.7 magnitude planetary shell to it. Small and medium-sized telescopes will show the 11th magnitude central star and also bright central arcs. In images, NGC 40 will show as sort of a bright red color from the ionized hydrogen within it. But again, a nice bright nebula that you can also see the central star in. Well, we're trying for tonight. Next up, NGC 6894, located in the summer constellation of Cygnus, the Swan, discovered by Herschel in 1784. The 12th magnitude dim ring-shaped planetary is located about 5,000 light years away. And again, has a dim central star of 17.6 magnitude. So pull out the big guns for this guy if you think you're going to try to see him. It's best visible medium to large telescopes from a dark sky location. And to me, it kind of looks like a little Fruit Loop Cheerio kind of up there in the sky. Next is also located in the summer constellation of Cygnus, NGC 6826, the blinking planetary. Was discovered by Herschel in 1793. The 10th magnitude planetary, located about 3,200 light years away from us, has a bright central star of 8.9 magnitude, making it an easy target for small telescopes. Visually, when observing the bright central star directly, the nebula tends to disappear. Using your averted vision to see the nebula causes the central star to disappear. Hence, it's nicknamed the blinking planetary. And again, this is a fairly recent image from Cherry Springs, I believe. I was able to get, there's like an outer shell that you can pick up. NGC 6905, located in the summer constellation of Delphinius, discovered by the Herschels in 1784. The blue flash nebula, again, a hint of its color, is an oval-shaped 11th magnitude planetary, 13.5 magnitude central star, a distance of about 4,200 light years. Visually, the planetary nebula is fairly bright in small to medium telescopes, and it does show a bluish color in the larger telescopes. So again, a pretty little object to try for. Finally, NGC 6445, located in the summer constellation of Sagittarius, discovered by Herschel in 1786. It's nicknamed the Box Nebula. NGC 6445 is about 3,200 light years distant, diameter of almost 4 light years across. Visually, it's a small, faint nebula, has a little rectangular shape to it, not really a disk. Best suited again for the larger aperture telescopes. Has a very, very faint 19th magnitude central star, visible only in 30 inches or larger telescopes. I couldn't even pull it out with my 8-inch imaging kit here. It's very faint. Rudolf Minkowski. Now let's move on to the modern era. German-American astrophysicist Rudolf Minkowski, born on May 28, 1885 in Strasbourg, Germany. 1913, Minkowski enrolled at the University of Breslau, studied physics, but he was drafted into the German army in 1914, served through World War II till it ended in 1918. Went back to university where he earned his PhD in 1921. 1922, he went to work for the University of Hamburg, first as an atomic physicist, but then later as an observational astronomer. In 1935, Minkowski accepted a research position at Mount Wilson Observatory, immigrated to the United States. Minkowski is best known for his Mount Wilson research work on supernova remnants with astrophysicist Walter Baade, which the two of them devised the spectral grouping of type 1 and type 2 classifications still used today to classify these supernova explosions, and also as a tool in determining cosmological distances to galaxies. But in the late 1940s, Minkowski published 3 versions of a paper that he titled New Emission Nebula, where Minkowski listed over 200 planetary nebula that he studied for their spectra, galactic distribution, and motion. In his papers, Minkowski didn't formally label his entries. He just referred to them by their right ascension and declination up in the night sky. But later, when they were all collected into a catalog, they were given designations based on which of his papers that they first appeared in. So an example, the Minkowski catalog designated the object M2-9, the Butterfly Nebula, is in the constellation of Fucus, is the ninth object from his second paper. That's how they got their name. So most of Minkowski's planetary nebula are very small and star-like, less than 10 arc seconds in diameter. They're also, most of them are very faint, greater than 13th magnitude. These are difficult visual observations to make. And they're not fun finding with an imaging kit either. Definitely a challenge. The best way to visually confirm, though, that you have found one is to use your UHC, narrowband filter, broadband filter, whatever kind you got, filter, rapidly pass it back and forth between your eyepiece and your eye, causing the planetary to blink in brightness from the surrounding field of stars. That's the best way to identify these guys. So let's look at a few examples of Minkowski's that if you're really tempted, you could try for. M1-74, located in the summer constellation of Aquila. It is a magnitude 12.9, and it just looks like a little star lost in a field of stars. M1-59, located in the constellation of Scutum. It is a magnitude 13.3, again, a faint little star, a little dust speck there. Now, this one might be a little bit easier to find. M1-64, located in the summer constellation of Lyra, the Lyra, kind of like right in the middle of the rectangular shaped body of Lyra. Magnitude 13.3. This one, it's hard to see in the image here, but it actually shows a little distended disk that you can see. And finally, M2-55 in the constellation of Cephus, actually in the general location of NGC40. So if you're hitting NGC40, just hop over to M2-55. But it's faint, magnitude 14.3, but it also displays a nice little disk for a Minkowski planetary nebula. But again, you're going to need large telescopes and filters to see these visually, or some type of an imaging kit. Let's talk about George Abell. American astrophysicist George Abell, born on March 27, 1927, Los Angeles, California. As a young boy growing up, George's father would take him to various LA museums, including the Griffith Observatory and Planetarium. This led to George developing an interest in science and astronomy, which he excelled at in high school. After graduating from high school in 1945, George first enrolled in the Navy. He wanted to be a Navy pilot, but the war ended before he could graduate from pilot school. So eventually, he was released from service. He enrolled back at Caltech, where he studied physics and astronomy. He graduated in 1951 with a BS in astronomy, and he continued on for his master's in 1952, and finally his doctorate in 1957. Abell's first professional job was as a Caltech astronomer, working on the National Geographic Society's Palomar Observatory Sky Survey, created using the Palomar 48-inch Schmidt telescope. George's primary research job was to review the POSS survey plates, looking for galaxy clusters. That's what he was looking for. But while searching through the plates for these galaxy clusters, he ran across a number of unreported planetary nebula. From the new data contained on the plates, Abell compiled a list of 86 very old and faint planetary nebula, which he published in 1966. And actually, of those 86 nebula, really only 82 of them are planetary nebula. One is a galaxy, another is a faint reflection nebula, and the other two are plate defects, essentially. So there's really only 82 of these guys to look for. Abell's catalog is recognized today as an excellent compilation of faint, challenging planetaries for the visual observer with access to large telescopes in dark skies and to imagers using either EAA or video astronomy, we used to call it, or more traditional astrophotography cameras. Over half of the Abell planetary nebula have central stars of 17th magnitude or fainter. So again, just to give you an idea, these guys are faint and extended. Interestingly, back in the early 1980s, before the large Dobsonian revolution took hold, George Abell was once asked by an amateur astronomer about observing his planetaries. Now, being more of a theorist than an observational astronomer, Abell replied that he doubted that any of them would ever be visually observable. And maybe it might be possible to photograph a handful of them. Of course, today we know that numerous amateur astronomers armed with large telescopes, 20 inches or greater in size, or using state-of-the-art imaging telescopes and cameras, are routinely observing and imaging all of this planetary nebula. Now, I've done that using EAA techniques. Now, generally, it's best to save hunting Abell planetaries for trips to dark sky locations and also nights of excellent transparency. You don't want any smoke up there in the sky. Visual observers must be completely dark adapted and to avoid all lights during observations. This is not where you want to flash your eye with that white light. You don't want to do that with Abell planetary. It's not going to work. While some Abells can be observed using smaller telescopes, medium-sized telescopes, most of these objects will require larger telescopes, again, 20 inches or greater size. So let's step through a few examples of Abells, starting with Abell 50. Abell 50 is also known as NGC 6742, which gives you a clue that this guy might actually be observable. Located in the fall constellation, of Draco. Its magnitude 13.4. Again, it's just a small little faint disk up there. Here's a more recent slide. It does have a little bit of a greenish shape to it, but not hard to find and definitely visible in medium-sized telescopes. Abell 81, known as IC 1454, located in the fall constellation of Cephus, magnitude 14.8. It looks like a tiny little Cheerio again, a little version of the Ring Nebula up there in the sky. And these are some older images, black and white, I used using an old black and white monochrome analog video astronomy camera. Abell 56. This is located in the summer constellation of Aquila, so it's going to be well placed tonight. Magnitude 15.5. This guy is very large and exceedingly faint. There's faint little ring up there. I'm not sure if you're going to be able to see this guy even with a 30-inch telescope. I'm thinking this is more of a imaging type situation here. But if you've got a 30-inch telescope, why not try? Finally, Abell, I lost track where I'm at. Abell 61. This is also located in Cygnus, a swan, magnitude 14.4. This guy is one of those ethereal-looking soap bubbles. Again, very diffuse, very difficult visual. It was a difficult imaging project too. Abell 71, also located in the constellation of Cygnus, magnitude 15.2. This one is actually somewhat bright, and you can actually probably pick this up in a medium-sized telescope. So this would be a good Abell planetary to try for. And definitely well placed tonight. Finally, Abell 66 in the constellation Sagittarius, way over toward the border of Capricornus. Magnitude 14.9. Again, this huge, extended, faint soap bubble of a planetary nebula up there in the sky. Another difficult visual observation, and also it took at least 15 minutes of 3-minute exposure to pull this out. But let me tell you, when I saw this thing appear on the screen, I was jumping for joy. It's beautiful. All right, let's wrap up this talk, and we'll take some questions, and let's get up here and we'll look at some planetaries. So today, I've introduced you to a class of colorful, luminescent, wispy shells of deep sky objects and some of their catalogs. We've learned a little bit about the historical and modern individuals behind each catalog. We've looked at lots of professional color photographs, along with some amateur sketches and amateur images of some various members from these catalogs. So hopefully this little presentation has inspired you to search out and explore these very rewarding celestial objects up there in the night sky. So I encourage everyone to get out tonight when we're done and try your hand at finding and observing the ghostly disk of these elusive deep sky objects. The Planetary Nebula, Charles Messier, William Herschel, Rudolph Minkowski, and George Abell. And that does conclude my presentation. Again, on my handout, it has my website on there. If you go to my website, you can you go to my website, you scroll down, you'll actually find a little Abell Planetary Nebula tour where I image or sketch my way through all the Abells. But you'll find in the PDF download section, you'll find this presentation there, along with a little chart addendum. Though I highly recommend you go to Alvin Huey's faintfuzzies.com website, download his Finder chart books, use those as a tool. Books, there's lots of great books out there on Planetary Nebula, some of which I've talked about tonight. Also magazines. It seems like every other month, one of the major astronomy magazines has an article on observing planetary nebula, sky and telescope astronomy. Lots of good places. Of course, the internet can be your friend. Just Google planetary nebula and you'll find all kinds of great information about them. And just credits, all the professional images I displayed all came from the NOAO. Imager Adam Block had his hand in most of those. Of course, the amateur sketches and pictures were yours truly. That does conclude my presentation. I will be happy to take any questions you might have on planetary nebula. And look, it's not even 9 o'clock yet. So, anyone have any questions? Yes.
Yeah, two-part question. When a star becomes a white dwarf, does the gravity cause the nebula to disappear? And secondly, what happens after the star goes supernova? Does like a completely new nebula reappear or something?
So those are actually two different types of explosions. So the white dwarf, what it does is, as it's collapsing from a red giant stage, it sort of puffs off these shells of gas multiple times. And those shells will escape from the gravity of the white dwarf. They just slowly expand out into space and they disperse. And of course, as the star collapses down to white dwarf, the light from this white dwarf dies down. Those shells basically go dark. They're still there, still out there expanding in space, again, to be swept up in the future to create new stars. This is where like all the metals, the heavy elements on the Earth came from other stars that went through that process of puffing out those shells. Supernova explosions are a little bit different. That's where the whole kit caboodle goes kaboom, and it violently blows that stuff out into the universe. Not sure if that answers that second part of your question.
Nebula is created from the supernova, or
yes, they will create, but those aren't really. I don't think they're really classified as planetary nebula. They're more classified as supernova remnants.
So it look completely different from the original one.
Supernova remnants are different from planetary nebula, and it's a different process how you get to each one of those two. So, good question. Thank you. Anyone else have questions? Yes.
So did Minkowski have?
He used the yes, thank you. The Palomar, yeah. And again, it was strictly astrophotography. At this point, modern astronomers they all look through telescopes. So just taking pictures of the plates, studying them, and it's like, oh, what's this thing here? And he started making his list of these planetary nebula. Yes.
Planetary nebula.
I'm sorry.
What's the closest?
The closest one, that was shoot. Now I know the biggest and the brightest. I don't know the closest. That's a good question. Yeah. I don't know. You stumped me. You want a piece of cake? Good question. No, good question. Now I'm going to have to go look that up now. Any other questions? Hopefully I can answer. All right. Well, you know what? Again, thank you all very much. I appreciate it's an honor being here. Thank you.